Hello again, and welcome to Mr. Rohrman's chemistry class. This is our second part of lesson 2, which is going to be on solubility curves and what they're all about. So the standard again for today's class is going to be TEACS 11.C, which is to investigate how solid and gas solubilities are influenced by temperatures using solubility curves and how dissolution rates are influenced by temperature, agitation, and surface area. And the learning objective for today is we're going to learn how to use Henry's law to explain how pressure affects the solubility of gaseous solutes in solutions. So again, quick refresher before we move on, talking about solubility. Solubility is a measure of how much solute will dissolve in a solvent. Again, we're talking about factors such as temperature that affect whether more of the solute will dissolve into the solvent or not. So Henry's law basically states that the amount of a gas that is dissolved in a liquid is directly proportional to the partial pressure of that gas above the liquid. So as you can see in the diagram on the left side, we have a pressurized container, and on the right side we see the after effect of the partial pressure of the gas. Notice the difference between the gas on the left and the gas on the right. This is what Henry law tells us about the direct proportionality of that pressure to the gas above the liquid. So this is what a solubility curve looks like. Basically what it is, it's a plot of solubility versus temperature. So you have your x-axis and your y-axis. On your x-axis you see the temperature in degrees of Celsius, and on your y-axis you see the solubility in grams per 100 grams of water. So the line represents the saturated solution. Points below the line represent unsaturated solutions, and points above the line represent a supersaturated solution, and that is how we read it. So in the next case here, on how we read the solubility curves, we can see, for example, how would we describe a solution that has 40 grams of potassium nitrate dissolved at 60 degrees Celsius. So we read it just like we read right and up. So we go to 60 degrees, and then we go up until we hit the formula for KNO3, which is potassium nitrate, and where those lines intersect, that's going to tell us what type of solution it is. And since it's again above the line, we see the line there, then we know that that is an unsaturated solution. And again, we look at how we describe the solution at 40 degrees. 40 grams of sodium chloride dissolved at 90 degrees Celsius. So we go all the way to the right to 90, and then go up to 40 grams, and then we can see the sodium chloride, NaCl, and we see that that is a saturated solution. Okay. Again, we talked about how solubility is affected by rates such as temperature, surface area, and we also discussed Henry's law and how we use that to explain pressures of the solubility of gases in these solutions. Next thing you need to do is to go ahead and click on the link below, take the lesson quiz for the lesson today, and that'll get submitted, and we'll get that entered into our grade book for you, and we'll move on to our next lesson. Thank you.